For generations, humanity has looked into the night sky and wondered how the universe began, how it evolved, and what its ultimate destiny might be. Every new telescope has opened another window into that enormous cosmic landscape. But the James Webb Space Telescope has taken that view farther than ever before, allowing astronomers to study galaxies whose light has traveled across billions of years. Some of the observations have raised fascinating questions about how quickly galaxies formed in the early universe and why certain distant objects appear unexpectedly bright or mature. Online discussions have sometimes transformed these discoveries into claims that hundreds of trillions of stars have literally disappeared. That dramatic interpretation is not supported by current evidence. Yet the real science behind the story is still extraordinary. The James Webb Space Telescope, launched in 2021, was designed to observe infrared light. Because the universe has been expanding, light from extremely distant galaxies becomes stretched toward longer wavelengths. This effect, known as cosmological redshift, allows astronomers to study objects as they appeared when the universe was much younger. In a sense, Webb acts like a time machine. When scientists observe a galaxy billions of light-years away, they are seeing ancient light that began its journey long before humans existed. But the deeper astronomers look, the more complicated the picture becomes. Some early galaxies appear surprisingly massive, luminous, or chemically developed for the relatively young age of the universe in which they are observed. These findings do not automatically destroy the Big Bang model, but they do challenge scientists to improve their understanding of how quickly stars and galaxies could assemble after the universe became transparent. There is another important mystery. When astronomers compare observations from different instruments and wavelengths, some objects that are obvious in one survey can be extremely difficult to detect in another. Dust can block visible light. Stellar populations can change dramatically. Galaxies can merge, fade, or become dominated by different wavelengths of radiation. What appears to be a missing object may therefore be a problem of detection rather than actual disappearance. This distinction is crucial. Stars do not simply vanish from existence without leaving physical consequences. Massive stars can explode, collapse into compact remnants, or gradually fade. Entire galaxies can also become difficult to observe as cosmic expansion stretches their light farther into the infrared. And this brings us to one of the greatest discoveries in modern cosmology. The universe is expanding, and that expansion is accelerating. Dark energy is the name scientists give to whatever is driving this accelerated expansion. It appears to account for roughly 70% of the universe's total energy budget, although its true nature remains unknown. As space expands, distant galaxies become increasingly difficult to reach and observe. Some regions will eventually lie beyond our cosmic horizon, meaning light emitted there in the future may never reach Earth. So while the idea of hundreds of trillions of stars mysteriously disappearing is sensational, the real story may be even more profound. The universe is constantly changing. Galaxies evolve. Stars are born and die. Light becomes stretched. Cosmic distances grow. And every observation from Webb gives scientists another piece of a puzzle that is billions of years old. But the biggest question remains: could these discoveries reveal that our picture of cosmic history is incomplete? To explore that possibility, we need to look beyond the headlines and deeper into what Webb is actually seeing. The most astonishing part of modern cosmology may not be what the James Webb Space Telescope can see, but what the universe may eventually prevent us from seeing. The cosmos is expanding in every direction. Galaxies that are not gravitationally bound to our local neighborhood are gradually becoming more distant. Because this expansion is accelerating, there are regions of space whose future light will never reach us. That does not mean galaxies are suddenly disappearing from existence. Instead, they are becoming increasingly inaccessible to observation. Imagine standing on an island surrounded by an enormous ocean. The island remains intact, but the distance between you and other islands continues to grow. Eventually, some of those distant islands could disappear beyond the horizon. The same basic idea applies on a cosmic scale, although the physics is far more complicated. The observable universe is roughly 93 billion light-years across today. Yet the universe itself may extend far beyond what we can observe. We cannot simply look farther and farther forever because light needs time to travel, and expanding space changes the paths that light takes. This creates a cosmic horizon. For astronomers, that horizon is not merely a philosophical concept. It is an important part of understanding the universe's future. Webb's observations of extremely distant galaxies provide a glimpse into earlier cosmic epochs. Some galaxies formed only a few 100 million years after the beginning of cosmic expansion. Studying them helps scientists determine how quickly the first stars, galaxies, and heavy elements emerged. Every unexpected observation becomes another test for existing theories. Perhaps some galaxies formed more efficiently than scientists previously believed. Perhaps early stars were unusually massive. Perhaps black holes grew faster than expected. Or perhaps current models require new physics. But none of these possibilities means scientists have proven that the Big Bang was wrong. The Big Bang describes the universe evolving from an extremely hot, dense early state. It does not provide a simple explanation for every detail of galaxy formation. In fact, modern cosmology continuously changes as new evidence becomes available. That is the strength of science. A surprising observation does not automatically destroy a theory. Instead, it forces researchers to ask better questions. Could dark energy change with time? Could our understanding of gravity require refinement? Could the earliest galaxies have developed through processes that current simulations do not fully capture? These questions remain open. And then there is the most speculative possibility. What if some future discovery reveals an entirely new property of space and time? That idea belongs firmly in the realm of speculation, but scientific history reminds us that the universe has repeatedly surprised humanity. Relativity changed our understanding of gravity. Quantum mechanics transformed our view of matter. The discovery of cosmic expansion changed the idea of a static universe. The next revolution could come from observations we have not yet imagined. For now, Webb continues to observe the ancient cosmos, gathering light that has traveled for billions of years before reaching its mirrors. Some objects will fade from view. Others will emerge from the darkness. New galaxies will challenge old assumptions, while better measurements will separate genuine mysteries from misunderstandings. The universe is not disappearing before our eyes. It is evolving. And humanity happens to exist during a remarkable moment when we possess instruments capable of witnessing that evolution. Every distant galaxy is a message from cosmic history. Every redshift carries information about expanding space. Every unexpected observation is an invitation to investigate further. The greatest mystery may not be that stars are vanishing. It may be that the universe is far more complex than we ever imagined, and we are only beginning to understand it.